Hey everyone, welcome back to the channel. Today we are going to tackle an interesting problem that's common in coding interview. It's all about calculating the product of an array except self without using division and in O and time. Sounds tricky, but don't worry, I'll break it down step by step and we'll even look at some clean C# code. Let's get started. So here's the problem. Given an array, integer array, you need to return an output array where each element is the product of all elements in the array except the one at the current index. For example, if the input is this, the output will be 24, 12, 8 and 6. Example 2. If the input is like this, the output will be 0, 0, 9, 0, 0. The key challenge is no division and the solution must run in O and time. Also a follow-up asks if we can do it in constant space. O1 extra space aside from the output array. Now I remember solving this for the first time during a technical interview. I thought, oh, easy. I'll just multiply everything together, divide by the current element. Then they said, no divisions allowed. And that's when things got interesting. I quickly realized there is a neat trick where you can compute the product of all elements by making two passes over the array. One for product before the current index and one for products after. Let's break that down. Here's the core idea. We'll create an empty results array in the first pass and we'll multiply everything to the left of the current element. In the second pass, we'll multiply everything to the right of the current element. It works because on the first pass, we only care about the product of elements before the current index. On the second pass, we only care about the product of elements after the current index. By combining these two passes, we'll get our desired result. Let's see how this looks in code. We'll walk through the code line by line. Int n equal to nums.len. Here we store the length of the input array. We initialize a new array result to store our final output. We start by setting the first element of result to 1. Why? Because there are no element to the left of index 0. The loop computes the product of all elements to the left of each element. As we move through the array, we multiply the previous result I minus 1 with nums minus 1, nums I minus 1 to get the left side product for the current index. Now we introduce right product to keep track of the product of elements to the right. This loop starts from the current index and works its way backward. We multiply each result I by the right product, which holds the product of all elements to the right of the current index. After each iteration, we update right product to include the current element, preparing it for the next iteration. And that's it. By making two passes, one forward and one backward, we efficiently compute the product of all elements except the current one. And remember, this was one of those elegant solutions where you really see the power of breaking down a complex problem into manageable parts. Instead of trying to solve everything in one go, you just make a couple of careful passes over the data. It's a technique that's useful in many problems and not just this one. To recap, we solved this problem in O and time without using divisions and with O1 extra space. This approach ensures efficiency while keeping the solution readable and maintainable. If you've enjoyed this breakdown, don't forget to like and subscribe. Drop a comment if you have any questions or suggestions for future videos.